So after trigonometric limits, let's move on to integration using partial fraction. Now, this method, that is integration using partial fraction, will be using only to solve rational fractions. Now, before I discuss what a rational function is, let's understand what a polynomial is. Any function of the form a0 to the power a0 into x to the power n plus a1 into x to the power n minus 1 given that a0 is not equal to 0 and a0, a1, a2 till an are all real numbers. Now this function, if it satisfies these two conditions, is known as a polynomial. Now if I have a fraction, let's say I have a fraction of the form px divided by qx, where both px and qx are polynomials, then this function, this overall function, is called a rational function. Now the partial fraction method which we'll be using only in case of rational functions. Okay. Now let's say that we have a rational function. I'll give you an example of a rational function. Let's say it's x plus 8 divided by 2x minus 3, 3x plus 5. Now in this case you can see that this is my px by qx. Okay. As you can see, both px and qx are polynomials, so this is a rational function. This function I can also write as you can see that if I simplify this, I'll get this equation again. So this is how I can simplify this. Now if I simplify this like this, then each of the fractions which I get are known as partial fractions. Now as you can see, this is a fraction, this is a fraction, so both of these are fractions. So why are they called partial fractions? Because partially they complete the whole fraction, which is this. Okay. Now how did I get this fraction, these two fractions? As you can see that this rational fraction has in the denominator two factors, 2x minus 3 and 3x plus 5, and ultimately I have expressed this whole rational function in terms of these two factors, 2x minus 3 and 3x plus 5. Okay. So now the question arises that if I have been given any function, then how do I simplify it into its rational component or into its partial fractions? The way is very simple. Let's see what I have done here. First of all, I just wrote the factors here, which are 2x minus 3 and 3x plus 5. Remember, these are the factors of the denominator. Okay. Now I wanted to find the values of a and b, so that this expression is similar to this expression. Now what I'll do, I'll simplify this. If I simplify this, I'll get a into 3x plus 5 minus b into 2x minus 3 divided by 2x minus 3 into 3x plus 5. Now what you can do is just put x equals to 3 by 2. Now when you put x equals to 3 by 2, what happens? What happens when you put x equals to 3 by 2? before you put x equals to 3 by 2, let's understand what exactly you wanted to do. See, this is equal to this. In the denominator, both the LHS and RHS are same, so you need to make the numerator equal. So to make the numerator equal, I'll first put the 0 of one of the factor. So 0 of this factor is 3 by 2. So let's put 3 by 2 on the numerator. When I put x equals to 3 by 2, what happens? This gets cancelled out. So when x equals to 3 by 2, okay, this should be equal to this, so that the numerator is equal. The numerator is obviously equal, so I need to make the numerator equal. So when I put x equals to 3 by 2, you will see that you will get a as 1. Similarly, when you put x equals to minus 5 by 3, you will see that you will get b as 1. Okay, so that's why I'll get a and b as 1. So this becomes similar to this expression. Now, well,